Okay, guys, this is a week to remind you of something very important from pre-cal that will never go away. And it really is to get you practicing it, but please bear in mind that this is something that you can't just do this week and then forget about for a month and then expect to be good at it. I recommend you do this lesson, but then you look back at the circle every time you're doing math the rest of summer. Just look at it for like 5 minutes, okay? And then that way when you get to school, you're going to be like, oh yeah, no big deal. We know everything about the unit circle. So just as a refresher, let's talk about, of course, the unit circle and sort of some memory tricks that you may or may not have talked about last year. Now, the way that I do this is, let me go ahead and select a different color here. Of course, we have a circle, yay. And let me put my X and Y axis on here. Okay, I usually only memorize quadrant 1, and then from there I have memory tricks to get me around the rest of the circle. Okay, so what I remember first is that anything close to the x-axis is going to be something over 6, okay? So like pi over 6 is here, but that means that this is something over 6, something over 6, something over 6. And the numbers are not too bad. I'll help you with that in just a second, but I'm going to go ahead and do this. These are all over 6, okay? Now, if you're in the middle of each quadrant, then you are something over 4, and of course the first quadrant's just pi over 4. But that means this is something over 4, this is something over 4, all the way down. So all of your, 45 degrees are going to be over 4. And then if you're close to the y-axis, these are going to be the over 3's. So pi over 3, over 3, over 3, and over 3. Okay, great. So I realize my proportions may be a little skewed, but this is how I teach my class to memorize it. So once we have quadrant 1 and we know that it goes 6, 4, 3, then everything else, like the top and the bottom of your circles, these are probably the ones you have memorized. These are the over 2's. So this is pi over 2. This is 2 pi over 2. Now 2 pi over 2 is just pi. This is 3 pi over 2. And this is 4 pi over 2, okay, or just 2 pi. So once you have those, let's come back in and talk about the memory tricks for the other quadrants, okay? Now here, look at your numerator. It's just pi, pi, pi. And if you remember about the denominators matching, whether you're closer to the y-axis or closer to the x-axis or in the middle of your quadrant, there's some memory tricks for the numerator over here as well. As you go around the circle, if you're in this quadrant, the numerator is the denominator minus 1, okay? So 3 minus 1 is 2, so this is a 2 pi. 4 minus 1 is 3, so this is a 3 pi, and that would be a 5 pi. If you're in the next quadrant, it's denominator plus 1. So 6 plus 1 is 7 pi, 5 pi, and 4 pi. And for the numerator over here, now I've heard two different memory tricks, okay? The way that I initially memorized it is I always would double my denominator, so 2 times the denominator, and then I would subtract 1. So double that and it's 6, and then 6 minus 1 is 5, so that would be 5 pi over 3. Double is 8, minus 1 is 7, double is 12, minus 1 is 11. I have also heard of this is kind of a cool way too. You see that blue line connected to this one? Well, if you shoot all the way across this blue line over into quadrant 2, I had some students that realized that if you just add denominator and numerator together, so 5 plus 6, you would get that 11. And it does work for everything right here. So if we're on the green line and we go across to quadrant 2, 3 plus 4 is 7. And then this one, 2 plus 3 is 5. So either way, it's going to work out famously for you. Just keep in mind that's the only quadrant where that relationship works, okay? But whatever you have to do, this is something you have to know. And of course you have to know the points to go with it. Now, I only ever, when I'm doing something for calculus, I only ever think about the first quadrant, because you should remember from last year that there's, symmetry everywhere, right? Symmetry all over the place. And because of that symmetry, writing over that, okay, you really only have to know the first two. This is root 3 over 2, 1/2, and this is root 2 over 2, root 2 over 2. If you know that, then you know that this one is just the inverse, where you just switch the 2 points. And if you're in any other quadrant, they match exactly. All you have to do is decide if it's negative or positive, right? Depending on the quadrant, whether it's going to be negative or positive. And then if you're here, of course, this is the point 1, 0, negative 1, 0, 0, let's see, this would be 0, 1, and then 0, negative 1. Okay, so these are your main points of your circle and what you're supposed to be able to do. Now, what do we do with this in calculus? Okay, the good news is you're never going to have to construct the entire unit circle. Okay, you're not going to have to do that for any purpose other than if you don't know it, you might have to, but hopefully you know it well enough to where you can answer trig functions. That is the ultimate goal. Okay, and it's not written on here, but seriously, the ultimate goal is to know how the circle relates to sine, cosine, and tangent, okay? How does circle relate to sine, cosine, and tangent? And I'm not going to list the others, but the other three as well, secant, cosecant, cotangent, okay? So what you're going to have to be able to do is to actually evaluate a trig function. So what this means is there's going to be a lot of times in calculus where you'll be in the middle of a problem and all of a sudden you'll be down to like the cosine of x is equal to 1/2. And you'll be having to solve that. And so what the idea is that you're supposed to remember that when you see cosine, that is the x-coordinate, and that this is telling you that, oh, okay, somebody has an x-coordinate of 1/2. Where does that happen? And so you would have to look back at your circle for where is the x-coordinate 1/2. Which when we look back up at our circle, the x-coordinate is 1/2 back up here, and that is at pi over 3. So we would write down pi over 3. But we also have to remember that these happen in multiple locations because there's another quadrant where the cosine is a positive 1/2, and that would be exactly underneath it. So it would be 5 pi over 3 as well because they're both positive. When you're in quadrant 4, your x is positive as well. So those would be my answers that I would report. And sometimes you'll have restrictions, but for right now, let's just talk about both places on the circle that work. Okay. The other thing is you might just straight up have to do something like you'll be in the middle of your work and you may be asked like find the tangent of, maybe it's like, 7 pi over 6. Okay, so if you're asked for the tangent of 7 pi over 6, then you have to remember that the tangent is equal to the y over the x. So therefore you'll have to think, okay, where is 7 pi over 6? Okay, well it's right here. And what's the coordinate that goes with it? Well, it's going to match the coordinate for normal pi over 6, which would be root 3 over 2, comma 1/2. But remember, in this quadrant, we're in the third quadrant, so everything's negative. Then we'd have to put the y over the x. So negative 1/2 over negative root 3 over 2, and then we would solve that out. So you know the drill. Fraction over fraction, flip the second, multiply, and we should get, what would that be? 1 over the square root of 3. They probably didn't like you to write it that way last year. You probably remember seeing root 3 over 3. So either of those will be fine. But these are the kinds of things that you're going to have to do, okay? Now, one other thing to keep in mind is what if you are given, this is kind of tricky, but sometimes you're given something like, find the sine of negative 3 pi over 2. Okay, remember that a negative on the angle does not necessarily mean a negative answer, okay? A negative on the angle means that I want you to travel around the unit circle clockwise instead of counterclockwise. So we need to go a distance of 3 pi over 2, but in the clockwise direction. So if you think about your circle, okay, that's going to mean instead of going like this to 3 pi over 2, we're going to go the other way. So all the way, that's 1 pi over 2, 2 pi over 2, 3 pi over 2. So you're really up here, and then you need to think about sine is the y value, correct? So the y value up there is a 1. So that's the kind of thing that you'll also have to do. So just remember to practice kind of making your way around the circle, practice memorizing those, and not having to look at the circle every time you do a problem, okay? Now, the inverse trig function. Okay, this is technically what we did right here. I mean, using an inverse trig function just means you know what the coordinate is and you have to figure out what the angle is. And so that's something you did last year, but what I want to do in this box is also make a note for inverse trig functions that there's times throughout calculus where you also might need to solve beyond just what's given, or you might need to kind of know what the graphs look like. So we're going to do both of those. We're going to think about the graphs of each of these, and then we're also going to answer a question. Okay, so like for example, you may have something like 2 sine x plus 1 equals 3. Okay, so if you have something like that, you're responsible for solving, which remember from last year, you could just move the 1 to the other side, divide by 2, and then ask yourself, okay, where on the circle is the sine 1, or where is the y value equal to 1? Well, we just did that over here. That would be a pi over 2. Would be my answer for that, okay? Now, as far as the graphs of these, the good news is, unless you're taking BC, I'm going to actually write this, BC only. If you're taking AB Cal, then go ahead and fast forward because you will not need this tidbit. But if you're taking BC Cal, keep in mind the graphs of the inverse trig functions. You know, inverse trig I can either write as tan inverse, okay, or I can write arctan. And this is a graph that shows up quite a bit, and a lot of people don't even remember it. These mean the same thing, okay, and you may have to know this parent function graph, and what this looks like is it's the inverse of the tangent graph. So if you remember that tangent is a bunch of waves, we're just going to take those waves and we are going to switch the x and the y. And what ends up happening is it forms a graph like this, and there's an asymptote up here at pi over 2, and there's an asymptote down here at negative pi over 2. So this is just a graph that shows up. You can also go look up arc sine and arc cosine if you want to, but they did not show up near as much as the graph of arctangent. So anyways, keep that in mind if you're taking BC. Okay, trig identities. This is something that most people are scared of and are like, oh my gosh, please tell me we're not going to have to do all those identities again and again and again. Okay, all that you need to know for identities is you need to know the reciprocal identities, and you maybe need to know Pythagorean. So here we go. Oops, woohoo. Okay, so everybody needs to know things like tangent. Like over here we said tangent's y over x, but it's also the same thing as sine over cosine. Okay, so you do need to know that. You need to know that cotangent would then be cosine over sine. Hopefully you remember these guys. Secant, do you remember who that went with? Secant was the reciprocal of cosine. And most people remember it's because these are, you remember the opposite letter thing. Secant goes with cosine. So cosecant must go with sine. These are the reciprocal identities. So everybody needs to know these. I also think that everybody still needs to remember at least 2 of the Pythagorean identities. That's what these were called, Pythagorean identities. So if you are in any kind of calculus, regular calculus, AB calculus, BC calculus, these you do need to know. Now, if you're taking BC calculus, you're also going to want to go ahead and take a look at the double angle identities. And not all of them, but these are the ones that kind of show up more than the rest, okay? This would be like the fact that cosine of 2x is actually equal to 2 cosine squared minus 1. Another way that we did this one was maybe we did it as 1 minus 2 cosine squared. Okay, so, oh, sorry, that's a sine. Haha, JK. Okay, so those are a couple of things that we used to write for this one. And then the sine of 2x is 2 sine cosine. Okay, so these two double angle ones, those also show up if you're taking BC Cal. Okay, so just good to remember and good to keep in mind. All right, cool. So what you're going to do now, guys, is try those problems that relate to the unit circle. They relate to solving trig functions and inverse trig functions. And then, of course, we can expand on that in tutorials. But this is the stuff, the building blocks for Cal that are recurring and show up all the time throughout the year. So, gots to know it.